Properties of amines. Chemical properties. First property, reaction with NaNO2 plus HCl at 0 to 5 degrees centigrade, or HNO2, nitrous acid, both are same. Reaction with NaNO2, sodium nitrite plus HCl at 0 to 5 degrees centigrade, or HNO2. I given this property for aniline, but for aliphatic, all type of amines. Clear? Right. Observe this chart carefully. Primary aliphatic. Primary aliphatic. Primary aromatic. Secondary aliphatic or aromatic. Secondary aliphatic or aromatic. Primary aliphatic amines when treated with NaNO2 plus HCl at 0 to 5 degrees centigrade. NaNO2 plus HCl, temperature condition is very, very important. Temperature conditions. Okay. First point, remember the gas released. Colorless gas is released by, I'll give the brief about the reaction. What is the final product, mechanism, everything we can discuss. First important point, colorless gas. N2 is released. A colorless gas is released, that is N2. A colorless gas is released. What is that colorless gas? Nitrogen. Very, very important. Only primary aliphatic amines when treated with NaNO2 plus HCl release colorless gas N2. This is the distinction test. Right? Only primary aliphatic. Right? Next. Primary aromatic, NaNO2 plus HCl at 0 to 5 degrees centigrade, produce a stable diazonium salt, benzene diazonium salt, stable diazonium salt. You know its name, benzene diazonium chloride. Benzene diazonium chloride is produced. Here also diazonium salt is formed, but that is unstable. Primary information. Okay, I am giving primary basic information, then we will go in depth. Right. Secondary aliphatic and aromatic when treated with NaNO2 plus HCl, they produce yellow oily drops. So we can expect one question. How many of the following amines produce colorless gas N2? How many of the following amines produce colorless gas N2? How many of the following amines produce yellow oily drops? Secondary aliphatic and aromatic, both. Right. This is very important chart for the distinction of amines. Okay. Let us see the reaction briefly. What happens when we treat primary aliphatic amine with NaNO2 plus HCl? Right. RCH2NH2. First heading, primary amine, that too aliphatic. We wrote chart. Okay, brief discussion about the chart. Tell me primary amines when treated with NaNO2 plus HCl at 0 to 5 degrees centigrade. Release colorless gas, that is nitrogen, right? So before releasing nitrogen, let us see what happens. First they produce unstable diazonium salt, very important. Primary aromatic produce stable diazonium salt, stable diazonium salt. Stable diazonium salt. Primary aliphatic produce unstable diazonium salt. This is unstable. Aliphatic primary produce unstable diazonium salt. This is unstable. Primary aromatic produce stable diazonium salt. That is benzene diazonium chloride. This is unstable diazonium salt. I said this is unstable. So after some time, what happens? It will dissociate into, you tell me, this is carbocation plus nitrogen gas and Cl negative, unstable, so undergo decomposition. Primary aliphatic amines produce unstable diazonium salt that undergo decomposition to produce carbocation and colorless gas nitrogen. Very important question. An organic compound containing nitrogen liberate colorless gas N2. Identify that organic compound. Model question. So primary amine, you know already about classification of amines, and you know about nomenclature also, right? Okay. Nitrogen is released, and which is formed? Carbocation is formed. And look at this. From this carbocation, 3 products are formed. 3 products. Look at this. We will see one example, then you can understand. This is CH2 plus RCH2OH. How OH will attach? I'll explain. What is the source of OH? Where it is coming? OH. The OH is not there, no, in the reaction mixture, but it is there. I'll explain. Major product, very important point. The major product is alcohol. When primary aliphatic amines treated with benzene diazonium salt, they produce colorless gas nitrogen, as well as they produce alcohol as the major product. Major product is the alcohol. Next, primary amines do alkyl halide also. What is the source of alkyl halide? LCl negative is there. That Cl negative attach carbocation, right? And they produce alkene also. How alkene is formed? I'll tell you. Write directly alkene. So you have to remember 3 products are formed. Alcohol, alkyl halide, alkene. We will see the mechanism. This is general reaction. I took RCH. This is general reaction. So very important point. Liberation of colorless gas, that is nitrogen, and the major product is alcohol. Alcohol is the major product. Okay, right. Let us take one example. Sorry. Nitrogen is colorless gas. Who said? Adiba? NO2, you are, I think you are asking about NO2. Brown color gas, NO2. Nitrogen is a colorless. In air, what is the percentage? More composition is nitrogen only. No? Air is colorless. See first example. CH3, CH2OH, one product. Second one CH3, CH2, Cl. Third product alkene, and another one colorless gas. Nitrogen is liberated. These are the products, but major product is alcohol is the major product. Alcohol is the major. Let us see the mechanism. CH3, CH2, NH2, NaNO2 plus HCl 0 to 5 degrees centigrade. Temperature conditions are important. So first we will get unstable, tell me unstable diazonium salt, Rn2 plus Cl minus, Rn2 plus Cl minus. This is unstable, this is unstable. So immediately what happens? Decompose, undergo decomposition. Undergo decomposition to give carbocation CH3, CH2 positive. Just you imagine this bond will break. Nitrogen with positive is unstable, no? Okay. So this bond will shift onto the nitrogen with positive. So nitrogen will eliminate and this carbon will get a positive charge. Why? Because carbon is losing the bond. N2 and Cl negative. Cl negative also will separate. Cl negative also will separate. Okay. Colorless gas nitrogen. Clear up to this? Okay, everyone. Let us consider it as a step 1. Now, take this carbocation. CH3, CH2 positive. When it is attacked by OH minus, alcohol is produced. But what is the source of OH minus? What is the source of OH minus? What I wrote at the beginning? What I wrote? HNO2. HNO2. When NaNO2 and HCl both combines, they form HNO2. We can write HNO2 like this. Can we write HNO2? HNO2. Okay. From this, see, OH minus will separate to produce NO plus. So this is about source of OH negative. Source of OH negative. I am giving here. That's why I took directly. In the bracket I am writing HNO2 can be written as OH and NO. HNO2. It will dissociate into OH minus and NO plus. So this is the source of OH minus. Right? At the beginning we mentioned the reagent as HNO2 also. From HNO2 OH minus will come. Right. This is about formation of alcohol. Major product. Next another product is, what is another product? Alkyl halide. Alkyl halide. Alkyl halide. CH3, CH2, Cl. Alkyl halide is easy only, na? What is the source of Cl negative? Cl negative is formed here, right? Cl negative. Okay. Next alkene is also formed. Alkene. Can I write CH3 like this? CH2 H. And again this base OH negative, this OH negative capture this hydrogen and this bond will shift to this side to form alkene. This is about a complete mechanism, step by step mechanism. One is preparation of alcohol, production of alkyl halide and production of alkene. But out of these three, which is major? Alcohol is the major product. Clear? What is the name of this alcohol? Ethyl alcohol. Ethyl alcohol or ethanol. Ethyl alcohol are also called ethanol. Okay. Take white paper, all of you. Online students, you also say the product name here. I'm giving one amine to you. Say the names of the products. NaNO2 plus HCl 0 to 5 degrees centigrade. Say the names of the products. What is its name? What is its name? What is the name of this amine? 1-propanamine. 1-propanamine. Say fastly. Give IUPAC names. Give IUPAC name. Sujan. But your answer is wrong. Your answer is wrong. 1-propanol is wrong answer. 1-propanol is wrong answer. Look at this. Which compound I given to you? Yes. Look at this. See, I am writing the product 2-propanol. 2-propanol. What about GOC? Did you forget GOC? General organic chemistry. 2-propanol, 2-propyl chloride. Okay, and propene. These are the products. And the colorless gas N2. N2 is common. Colorless gas N2. In today's paper, what we discussed in the organic chemistry, majority of the questions from the discussion only. You can check once. Guessing questions in the organic is easy only. Don't neglect any exceptional cases like this. Clear? This is not exception, but we use general organic chemistry concept. Let us start the mechanism. Major product is alcohol, always, no doubt in that. Chloride, alkene, colorless gas N2. Let us see. See the mechanism? Right. CH3, CH2, CH2, NH2. NaNO2, HCl, 0 to 5 degrees centigrade. I am writing unstable diazonium salt first, R, N2 plus and Cl negative. Right? This is unstable, this is unstable. You will get carbocation, CH3, CH2 positive, and nitrogen gas and chloride is liberated. This is which degree carbocation? 1 degree carbocation. 1 degree carbocation. You know very well about that rearrangement. You are doing rearrangement from the first chapter onwards, right? Rearrangement concept. Let us consider this as a step 1, formation of carbocation. Step 2, rearrangement. I am taking that carbocation, this carbocation, and writing one CH2 group like this, CHH. Right? Do the shifting hydride. H minus. This is 1 degree carbocation. 1 degree carbocation is unstable. So what happens? Rearrangement takes place and we'll get a 2 degree carbocation. Very, very important example. Right? So 1-propanamine produces 2 degree alcohol, not 1 degree alcohol. Right? So from this, OH minus will give alcohol, Cl minus will give alkene, loss of proton will give alkene, CH3, CHOH, CH3 and okay, right. Take screen. Aminomethyl cycloalkenes. Aminomethyl cycloalkanes undergo ring expansion. Aminomethyl cycloalkanes. Look at this. What is its name? Aminomethyl. Don't write. Aminomethyl cycloalkane. Aminomethyl cyclopentane. Tell me. Aminomethyl cyclopropane. ఏమైంది నామిన్క్లేచర్ రాదా? మరి చెప్పొచ్చు కదా కాన్ఫిడెంట్గా, గట్టిగా చెప్పట్లేదు మీరు. ఎమినోమిథైల్ సైక్లోప్రోపేన్ లేకుంటే భయపడుతున్నారా నన్ను చూసామని? అట్లేం లేదు కదా. ఆన్లైన్ స్టూడెంట్స్, డిడ్ యూ గెట్ దిస్ స్టేట్మెంట్? సెన్సార్లో కట్ చేద్దాం దీన్ని మనం. ఎమినోమిథైల్ cycloalkane, cyclopentane, cyclopropane, cyclobutane undergo ring expansion. We took normal examples, right? We took propanamine, we took ethanamine. Now let us take different amine. Aminomethyl cycloalkane. This is also amine only, na? Primary amine or not? Aliphatic or not? Aliphatic only. Not connected to benzene ring. Not connected to benzene ring. If NH2 is connected to benzene ring, that is aromatic. Yeah? Let us take one example. Guess the product. What is the final product generally? Tell me. Alcohol is the final product. Yes. See, if you go normal, yes, normal mechanism, we remove this. Okay. Where carbocation is formed. OH, Cl, and alkene also. But see, let us focus on the major product. Okay, cyclobutanol is the answer. Very, very important. Let us see the mechanism. 3-membered ring is converted to 4-membered ring. Next reaction, see, aminomethyl cycloalkane undergo ring expansion. See this example. Aminomethyl cyclopropane, when treated with NaNO2 plus HCl, it is giving cyclobutanol after ring expansion. See the mechanism. Same reagent. First, what is formed? Tell me. Unstable? No. First, unstable diazonium salt. This is unstable, so undergo decomposition to give carbocation and nitrogen, colorless gas. CH2 positive, N2 and Cl negative. Let us consider it as a step 1. Okay. I am taking this carbocation. Step 2, ring expansion. See this pink color bond. You are not new to ring expansion. Where you did ring expansion? In alkyl halides. In alkyl halides. Why ring expansion is taking place? Very easy concept. This is pink color, right? Bond is pink in color, or consider this as a pink color bond. Cut the bond at this point. At this point, this is carbon atom. Detach the bond. Attaching, detaching. Detach the bond. Now the bond is in your hand. Attach here. At this dot, pink bond is attached or not? To this dot. Detach the bond and attach to this carbocation. Like this. See. Let us give the numbering 1, 2, 3, 4. We are detaching this bond and attaching here, right? 1, 2, 3, 4. Now you tell me which carbon will get a positive charge in this structure. Which will get positive? Second carbon. From this dot you are removing the bond, right? Like this. So this dot is losing the bond. So this dot will get a positive. This is which member ring? How many carbons are there? 4. 4 member ring. So you can draw like this also. Cyclobutyl carbocation. Why it is happening? Because in that first chapter I explained, low member rings are unstable. 3 member ring is unstable than 4 member. 4 member ring is unstable than 5 member. That's why ring expansion takes place. Lower member ring try to exist in the form of high member rings. Okay. So this is 3 member or not? So unstable. That's why it is converted to 4 member. Cyclobutyl carbocation. And you can draw that alcohol. OH minus gives rise to cyclobutanol. If we add chlorine, Cl negative chloride ion, cyclobutyl chloride. Okay. The major product is cyclobutanol. Got it? All of you? Online students. Is it clear for everyone? Okay. Once read this statement. Demjanov rearrangement, scientist name. Demjanov rearrangement. We did one reaction, na? That is Demjanov's reaction. Demjanov rearrangement. What is Demjanov rearrangement? This one, aminomethyl cycloalkanes undergo ring expansion. When treated with NaNO2 plus HCl. Demjanov rearrangement. The name is not important, but you have to identify when you get aminomethyl cycloalkanes, you have to do ring expansion. Got it? Secondary aliphatic and secondary aromatic amines. Reaction of secondary aliphatic or aromatic. This is having special name Lieberman's nitroso reaction. Lieberman's nitroso test or reaction. Lieberman's nitroso test or Lieberman's nitroso reaction. All are same only. Lieberman's nitroso test, Lieberman's nitroso reaction. Yes. You tell me. This is which amine? First point, secondary. Aliphatic or aromatic? Aliphatic. You can take in case of RPH benzene, then that is aromatic. Aromatic. It is treated with NaNO2 plus HCl at 0 to 5 degrees centigrade. Yellow oily drops. Yellow oily drops are observed. This is nitroso compound. Name of the compound is nitroso compound. Oil, yellow oil. This is also very important. Identify the amine which gives yellow oily drops when treated with NaNO2 plus HCl. Which amine? Secondary aliphatic and secondary aromatic. Both. Alright, let us see the reaction. One example. Online students, are you following? All of you. Hello. CH3 both. See. HNO2. How to write HNO2? When we mix NaNO2 plus HCl, we will get HNO2. HNO2 can be represented like this: OH, NO, HNO2. So from this two, we will get a HNO2. So I am writing OH and NO. Guess what will be eliminated? What will be eliminated? Water. H2O minus H2O. Then H3C, N, single bond N, between N and O double bond is present. This is called a nitroso compound. Complete name is not required. Just remember nitroso compound. That's why test name is Lieberman's nitroso reaction. Nitroso compounds. These are called NO link is called nitroso. Lieberman's nitroso reaction. Got it? This is applicable for both aliphatic as well as aromatic. Lieberman's nitroso test. Got it, all of you? Which amine gives colorless gas into primary aliphatic? Which amine gives stable diazonium salt? Primary aromatic. Which amine produce nitroso test, gives nitroso test? Secondary amine. Okay, let us do this question. An organic compound containing nitrogen liberate En2 gas. Identify the compound. First option aniline. Second option 2-butanamine. Third option N-methyl. N-methyl ethanamine. A, B, C. D option is none of the above. 2-butanamine. This is 2-butanamine. 2-butanamine is which amine? Primary amine. 2-butanamine. Okay, that's why nomenclature is very important for amines, because most of the questions are related to next. So you just go through the nomenclature again. We will do the questions, different questions. Right. Second property, reaction with Hinsberg reagent. Reaction with Hinsberg reagent. This is also used to distinguish primary, secondary, tertiary amine. Hinsberg reagent. Very important. Hinsberg, scientist name. Benzene sulfonyl chloride. Benzene sulfonyl chloride is called as Hinsberg reagent. Benzene sulfonyl chloride. Above reaction NaNO2 plus HCl is used to distinguish primary, secondary amines. Yes or no? We can distinguish primary, secondary, tertiary amines. Mainly primary and secondary. Tertiary, quaternary is not important. Just leave it. Okay. This is used to same distinguish primary, secondary, tertiary amine. How? In the previous case, colorless gas N2 is liberated. Yellow oily drop is produced. But how? In this case, look at this. Let us give abbreviation for this as HR, Hinsberg reagent. HR, Hinsberg reagent. Amine one degree. What is 1 degree amine format? R NH2. 2 degree amine R2 NH. 3 degree R3N. When primary amine treated with HR means Hinsberg reagent, it will produce N-alkyl benzene sulfonamide. N-alkyl benzene sulfonamide. You have to remember this. I'll explain how to remember this. N-alkyl benzene sulfonamide, and which is treated with NaOH, produce a soluble compound. How to identify primary amine? Primary amine when treated with a Hinsberg reagent, first it gives N-alkyl benzene sulfonamide. That N-alkyl benzene sulfonamide upon treatment with the NaOH produce soluble compound. Secondary amine when treated with the Hinsberg reagent produce N, N dialkyl benzene sulfonamide. N, N dialkyl benzene sulfonamide. It is when treated with NaOH, insoluble compound is formed. Insoluble compound. After seeing the reactions, you will understand easily, right? And what about tertiary amine when treated with Hinsberg reagent? They do not react. No reaction, or you can write directly no reaction. So primary amines, Q, N-alkyl benzene sulfonamide, which is when treated with NaOH, we get a soluble compound. Secondary amine, N comma N dialkyl benzene sulfonamide. It gives insoluble compound with NaOH. Tertiary amines do not react with the Hinsberg reagent. An amine which do not react with HR is which degree? 3 degree. Clear? Online students, got it? All of you. Adiba, you asked for Hinsberg, right? Now let us see the reaction briefly. After seeing the reaction, you can understand. First with the primary amine. Reaction of HR with primary amine, 1 degree amine. RNH2. This is primary amine. Hinsberg reagent structure, benzene sulfonyl chloride. This is Hinsberg reagent. Guess what will be eliminated from these two? What will be eliminated? HCl is eliminated minus HCl. Instead of by hearting, if you practice this reaction, you will remember easily. Clear? If you try to by heart, you will forget after some period of time. Right, remaining part R, NH, C. HCl is eliminated. Join these two, N and S. What is amide formula? Amide, RC double bond O NH2, amide. So N-alkyl benzene sulfonamide, that is the name. Clear? N-alkyl benzene sulfonamide. And only one alkyl group is present. N-alkyl, that alkyl group is attached to nitrogen. N-alkyl benzene ring is there. So benzene sulfonamide. N-alkyl benzene sulfonamide. You tell me when we treat amine with a strong base NaOH, what will happen? This is nitrogen act as a base. It donates lone pair as well as it act as acid also by giving H+. Why nitrogen gives hydrogen? Because that hydrogen is present on what? More electronegative nitrogen. So this OH minus capture hydrogen present on the nitrogen. See, if any atom, more electronegative atom contains hydrogen, that more electronegative atom gives that hydrogen. Are you getting what I am explaining? Nitrogen is more electronegative, that is having hydrogen, so it gives hydrogen. Here also see, nitrogen is having hydrogen. So if we treat this with the sodium hydroxide, this step is important. Sodium hydroxide, it acts like acid base reaction. This is a base. H will comes out from nitrogen, from this total structure. So acid base reaction. So we'll get a soluble salt, soluble compound. Proton donor is present or not here? So this is base. Proton donor nothing but acid. So this total compound serves as acid base. So what is the primary condition for this reaction? Presence of hydrogen on the nitrogen atom. Here I am writing acid base reaction. Condition for that reaction is presence of hydrogen on nitrogen atom. Now see what happens. Nitrogen loses H+. Okay. S double bond O. Negative. Can I write sodium plus? Acid base reaction, salt and water formation takes place or not? Once look at this, all of you, NaOH plus HCl. What is the product here? HOH will be eliminated. HOH is eliminated. This OH is eliminated. So Na and N will attach. Like Na plus and Cl minus. OH eliminated or not? OH eliminated. What is remaining? Na plus attaches to nitrogen. So soluble salt. Soluble salt. Like acid-base reaction. Acid-base reaction. Okay? Any doubt in this? OH. Here also OH. Clear? Right. So that is about a mechanism. You no need to learn this mechanism, but if you try to learn, you will understand the reaction easily. Right? Just to remember this point. So aromatic also. Primary, any type. Primary, aliphatic as well as aromatic also. All type of amines, primary amines. Right? Okay. What is the condition for this step? Presence of hydrogen, right? Observe carefully. N minus and Na plus. Salt, Na plus and Cl minus. Like that. Okay? Did you take screenshot, all of you? Online student. I also will send the notes. Next, what I am doing? You only tell me this is which degree amine. This is which degree amine? Secondary amine. Now we are taking secondary amine. What is the key step for this reaction? Presence of hydrogen and what? Hydrogen and nitrogen. But hydrogen is not there. And change the name also. N, N dialkyl. N, N dialkyl benzene sulfonamide. N, N dialkyl benzene sulfonamide. There is no hydrogen, right? There is no hydrogen. So there is no acid-base reaction. There is no salt formation. So we will get insoluble compound because hydrogen is not there. So this do not serve as acid. That's why we do not get salt, soluble salt. So we will get insoluble compound. Insoluble compound. An amine produced insoluble compound in the sequence with the Hinsberg reagent. What is that amine? Secondary amine, insoluble salt. Okay? Got it? All of you? Online students? Clear? Okay. With tertiary? You tell me, in the first step, what we are doing? We are removing hydrogen and chlorine. But if you take tertiary amine, where is hydrogen? There is hydrogen to remove. That's why 3 degree amines do not react with benzene sulfonyl chloride. No reaction. Because there is no hydrogen to remove. That is about the mechanism. If you see the mechanism, you can remember easily instead of by hearting. Clear? Right. Okay.